Good morning, everyone. Welcome to my second committee meeting. My name is Bao. Today, in this presentation, I would like to share with you all the work that I done in the previous year. Let's get started. So, in this presentation, I will have 5 parts. In the first part, I will explain about the introduction. The first introduction about my work, 3D printing technologies, and some problem and some solution I want to talk. Second, about the methodologies that I will use in my research. Third one is about experimental tests. I will explain on the test, on the classical test that I do in my study. The fourth part is about modeling, and the last one is my planning. The planning in the next year of doctoral student. That's all. And let's jump into the first part, introduction. Before start, I would like to share with you the first concept about 3D printing technologies. It is a additive manufacturing which creates a three-dimensional object layer by layer using a computer design. We can imagine a computer design is created inside a computer, and the signal will send to a printer, and the printer will print the element layer by layer. With this kind of technology, we can use various kinds of material. We could use high quality plastic to print fake arm or fake leg patient. We also can use cream or sugar to print a cake, and in terms of engineering, we can use metal to print high quality and lightweight for airplane. And with the 3D printing technology using mortar, in other words, we can call it 3D printing construction. It's also very developed in many countries. I can give you some example. In here we see a house which is printed by KMC in Belgium in 2020. This house have a very impressive thing, that is it is one single component house which was printed by a very large printer in here. In the right side of the slide, it is a commercial house by Icon company in Texas Hills. Icon is one of the first company in the world who offer a 3D printed house in the commercial level. According to Jason Ballard, the CEO and co-founder of Icon, 3D printing construction will be a way to offer high quality and faster house, and also more affordably. And this technology will be the build for the better. Why he is so confident about the future of these technologies, I would like to share you some advantage of this kind of technologies. The first advantage of 3D printing concrete, that is customization. There is no limitation with this kind of technology. We can create whatever we want with printing machine, with the printer. The second advantage is saving time and money. In both perspectives, 3D printing concrete can offer very good quality. Because of the automatic process, the building time can be 20 times faster, and because of the extremely accurate, it have to reduce up to 20% of the build cost. And the last one is high performances. According to some tests performed by Icon, their wall system in commercial house have 3.5 times stronger in mechanical strength compared to normal brick wall, and is more endurable with fire, water, and extreme weather. Because all of that technologies, me personally, I think it's time to change our modern lives, building use the same technologies 800 years ago. And and I think in the future, the future of construction is 3D printing technologies. In the next part, I would like to share with you the modernization problems, a problem that we are facing right now. A year on Earth, we produce 2.2 billion tons of solid waste. When we fulfill it in a cube, it can two times higher than the Burj Khalifa, the tallest building in the world. So unfortunately, the construction waste contribute up to 30% of total solid waste all over the world, the biggest number compared to other categories. And the construction waste can come from the increase of standard living lead to build new house, or it can be because the change in consumption habit. People want to build new house, so they want to build more. They want to build more new house, more modern house, and are also simplify this by the increase of population. And in most case, the construction waste ending up with landfill, which is very harmful for environment. As an engineer in material, I think I have to take some action to protect the world. So the best way to do that is recycle aggregate. We can be able to turn the construction waste from we are able to turn the construction waste into the new type of aggregate, which can be used in the new technologies. We will through the construction waste come from the demolition work, we can usable, and we deliver it into the recycle site. We crush it into smaller pieces and we sort them to have a homogeneous material. And after this step, we can have a new type of aggregate, a new type of material, which is ready to use in recycled concrete. We can use this concrete to build new house, new building. We can give them a new life cycle. So to create a new future, I would like to combine two of them: a problem to saving world and the technology for the future. I have my thesis, the behavior of fresh and hardened mortar with recycled fine aggregate for 3D printing. That is all about my first one, my past one. In the next part, I will explain about the methodology that I will use in my thesis. I asked myself 4 questions to answer the research study. The first one is, which test could be suitable to determine the real logical behavior of mortar. The second one is, what are the parameters I need to measure. The third one is how I can design a mixture for 3D printing concrete and using recycled material. The fourth one is how I can model the behavior of mortar inside the pi system. I will explain all these questions step by step. The first question, I have to choose the test, and I have to choose the test based on the existing material. So I will choose flow table test, the phone cone test, the V funnel test, and the piston test. To answer the second question, firstly, I have to know what kind of fluid the mortar is. In general, mortar is a non-Newtonian fluid, and more specific, that Bingham fluid. And the two most important parameter of Bingham fluid is the viscosity and the yield strength. And I have to measure these parameters, and I will use a recometer called RealCAD to measure these characteristics accurately. To answer the third question, how I can design a new mixture use recycled aggregate and suitable for 3D printing construction. I will start with the EN06, the standard mixture, and I will replace the natural sand with recycled sand. And after this step, we have a new kind of behavior. I guess this behavior will be very dry, and to attempt the characteristic which suitable for 3D printing concrete, I'm going to add in here some admixture. It could be mineral or chemical admixture, and I get the characteristic suitable for 3D printing through the commercial 3D printing product, and combine all of them. I will have a 3D printed mortar mixture using recycled sand. To answer the fourth question, I use two programs to run the modeling. The first on the primary software of me is OpenFOAM. This is a open source simulation. I can use this to simulate the behavior of fluid, and our material mortar is non-Newtonian fluid. This is perfect for this software. And the second is Python. Python is a sub-program. I use that to optimize the numerical program. Here is a summary of my methodology. I will start with develop material, commercial one, and I will measure their characteristic. I can put it in two ways. The first way is simulation program, and the second way is development. Second way is put these characteristics to develop a new recycled mixture, and combine these two, I have a final result. In the next part, I will explain about the experimental that I did. Before start, I will talk about the level of material that I use in this research. I'm a part of Big Truth project research about the 3D printing construction also. So in this thesis, I will use all five mixture come from Big Truth project. The reference mixture is follow the EN206, and I have also 4 different mixture in here: the clavic mortar, refractory concrete, Sika product, and composition Big Truth. And the orange number in here is the original water content. I change the water 1 or 2%, depend on the mixture, to test the robustness of the mixture. And here is all the classical tests that I perform on the mixture which I have, but unfortunately only two classical tests can show the suitable behavior for 3D printing mortar. With the V-Photo test, my material seemed to be too dry to flow out, and with the phone cone test, my material have no resistance against the cone tip. So to save time, I only show here the result of flow table test and the piston test. At the classical test, I have to measure the diameter of the sample on the table up to 15 times. Raise the table vertically. I repeat it 4 times at this minute, and here we have the result. So for easier comparison, I also add each chart in here the reference mixture EN206. This is the spread diameter of conventional mortar. We see that is around 15 centimeter, not too fluid. And the orange column in here is the spread diameter of original water content of 3D printed mortar. So we can compare these two to see the difference between the conventional mortar and 3D printed mixture. So obviously the 3D printed one have the behavior much more fluid compared to conventional mortar. Their spread diameter is around 20 centimeter. In here I have two mixture which is very sensitive, that is caloric matter and composition mixtures. When I add a little bit water, their behavior become very fluid, and when I decrease the content, it becomes super dry. I also have in here two mixture which is very stable. They are Sika product and refractory concrete. Sika product is they seem to be very stable with the changing of water content. When I change the water content, their behavior stay the same. It doesn't change so much. The next test I will introduce in here is the piston test. The purpose of this test is to test the printability and the buildability of the mixture. I also repeat it at this time, and unfortunately, with the limitation of this diameter of the nozzle, I cannot perform this test on all the mixture I have. Thus, Caloric motor Sika product can be printed because of the small aggregate. So in this here I just show the test of them, and I show the behavior of it. So with the caloric motor 10% water content, we see that their behavior is perfect for 3D printing construction. It can overlay easily 5 layers. The surface is very smooth, even 30 minutes. With the Sika product, in the initial time is still very fluid, but after 20 and 30 minutes, their behavior become more suitable. It's smooth, it can overlay more than 5 layers. And in the next part, I will talk about the real matter. In terms of real matter, there's no standard, and the purpose of this test is to measure the viscosity and the yield strength. I also repeat it 4 times at this minute, and here I got the result of caloric motor 10% and Sika product 18%. Caloric motor is also show the how to say stable behavior with time. The viscosity is still the same, around 2.5 pascal second, and the yield strength is it change with time. Start with around 7 and end with 21 pascal, but this number is quite small compared to other yield strength of other mixture. With the Sika product at the initial time, the viscosity, the yield strength of this product is quite identical compared to the previous one, but the viscosity is different. Thus, around 2 or 3 compared to 5, there are big jump. And in terms of yield strength, after 20 and 30 minutes, it changes dramatically. It can be increased with time. So after 20 and 30 minutes, the yield strength become very high, more than 80 pascal. That's not good for the printing process. And I have to combine 2 tests in here to find the optimal value for 3D printing motor. So in here, in caloric motor, I think the good buildability of this mixture is come from the viscosity. It can overlay easily 5 layer, very great surface. The surface is very smooth, so that's good. This mixture at 5 and 10 minutes, their behavior become very fluid, and the only difference between this mixture and this mixture is the viscosity. So with low viscosity, the buildability of this mixture is very terrible, but when the yield strength of this mixture is high, they have better behavior. It can overlay easy 5 layer and the surface is quite smooth. So I can get a conclusion in here that is for buildability we need high viscosity or high yield thread. But for better delivery the material inside the pie, I need low yield thread material. So combine two of them, I have the optimal value that is low yield thread between 6 to 21 Pascal and high viscosity around 5 Pascal a second. And in terms of mechanical test, I also want to study the impact of I want to study the impact of 3D printed sample on the mechanical strength. Here is how I print the sample, and here is how I cut the sample into the standard dimension, and here is how I do the flexural test and compressive test. I have three types of sample in here. I want to study also the printing speed on the mechanical strength, and here we got the result. In general, the flexural strength of this mixture is quite high. It can reach around 8 megapascal. This is great number even with the conventional mortar. And in terms of compressive strength, it can more or less reach the 50 megapascal in compressive strength, and it's also a high number. In general, we can say there's no effect on printing speed on this mechanical test, and the strength of 3D printed mixture sample is very good. The next part is modeling, and first program, the primary program in here is OpenFOAM. I had to got the material properties and I put it in the simulation program, and here I got the boundary condition, and this is my mesh. I have to divide the volume of the tube into many smaller elements to run the simulation. And here is the tube distribution in my modeling. Here is the inlet, and here is the outlet. The material will be transformed from the inlet to the outlet, and at the inlet pressure is 3 bar and the outlet pressure is 0. It's the atmospheric out pressure with the height of 0.7 meter. And I want to plot the velocity in two thread point of the tube, and here is the result. We see that the velocity in here is quite identical, so we can have one conclusion in here, that is in the straight part of the tube the velocity profile is the same. And in right now I want to study the velocity in the straight part and compare them to the curved part in my tube, and here I got the result. The velocity in the curved part, 0.3 and 0.4, quite similar, but it's very different from the 0.2. And to understand about this phenomenon, I decided to study one more point, that is 0.5, the point right before we have the curved part. And to understand, I have to take a closer look at the velocity profile in here. And in here, after the point, in here at the straight part, we see that the fastest area in the velocity profile is in the middle, but they have in this curved part they have changed their direction, but they cannot do that quickly because of the high momentum in here, so they cannot maintain the fastest area in the middle. They have a tendency to go further, go close to the zero, to go close to the wall, and then redistribution this velocity profile later on the straight part. So that's why we have this weird velocity. The fastest area is near the wall, near the zero, near the zero, and then it's become normal at the little point. That's all about the modeling. The modeling in the first modeling in my thesis, and the second one is Python. I use Python to test many other factors from. I use Python to test many to test many factors of my fluid. For example, in here I can plot the velocity profile inside of the pie, inside a straight pie, with the different stiffness of my material. My purpose in the near future is apply this Python code in all my entire tube, and to have a estimate to find out the practical the pressure value which is suitable for generate the laminar flow inside the pie. That is the end of part 4, and at the part 5 right now I will talk about my planning in the next year. In the previous year I done the bibliography and mostly on the experimental test to determine the optimal characteristic of a 3-bit motor. In the year I will focus on Python. I also quite finished the open form modeling, and I will focus on Python. And the next step in the next year is write my first paper. And at the year 2025 I want to develop the new major, and then I'm going to write my second paper. And at the last year 2025 and 2026 I will focus on writing my thesis and defend it. Here is all the doctoral activities I would like to attend in the next year. Some important a frame course in terms of transferable skill, scientific with scientific product. I want to write a paper which equal to 12 credit, and at the term multi-training I want to attend for this course of Mr. Luca course, which equal to 5 credits. And that's all about my presentation. Thank you very much for listening, and don't hesitate to ask me any question.